Wow. Amazing. Amazing job, everyone. Great, great work. Okay. Good morning, everyone, and welcome to AI Saturday Lagos Demo Day. My name is Tejumade Afonja, and I am the co-founder of this awesome community. And I have a lot of my colleagues, teammates, co-organizers, co-leaders on the call today to listen, to judge, to mentor our new scholars that we're about to hopefully graduate soon. All right. I wanted to start with a very short opening remark, and then I will pass on the mic to my colleague, Afolabi Animashaun, who will tell us about today's agenda and also say a bit of like some words about the entire mentorship program that we had this cohort, and also about the projects that we are expecting to talk about today. So AISST Lagos, I hope you know about us by now, and this is why you're here. But in just a very short, brief form, our community exists to help you be a kick-ass in AI. And we do this through different means, one of which is by teaching the core concepts in artificial intelligence. For this cohort, we're teaching data science and machine learning. So we help you be kickers through our cohort, 16 weeks cohort, or through hackathons where we invite you to come and share, like, unveil your skill set, what you know, and form teams with other people and earn some very cool prizes, hopefully. And we also do this through research where we think about problems in our society and we try to come up with solutions that we can work with and share this, our piece of work with the entire community, entire world, hoping that it would make a difference somehow. So we have been operating constantly, consistently for 5 years now, since 2018. Yes, January. And so far we've had more than now this is the eighth cohort. So we have over 800 scholars that have applied to join our cohort, and but we have more people within the community, of course, because I just told you that we do more than cohorts, right? We also do hackathons, we have colloquiums, we have the sometimes watch party, which is an idea we've been thinking about. So we have so much more going on in the community, and we hope that you can join us. I've already put a link here. You should join the movement. Once you sign up, we can send you our Discord link, and then you can be a part of our community. If you are not already part of our community, we invite you to do so. So what about cohort 8? So again, I already told you that we exist to help you be a kickers, and we want you to be competent in data science and machine learning. So our cohort 8 is specifically doing that. We want to help you build competence in data science. We received 175 responses to our call for application. And as you can see, week by week, we have more and more people come down the line. So this is our dashboard, our internal dashboard. When we started cohort, we started with about 827 active students, and like about 70 people show up in the first week every Saturday to learn. And as we proceed in the cohorts, we started to see some drop, which is natural for a very long streak of classes as we have. And about the peak, you'd see this is where we were ending like data science class and starting machine learning class, and you see some excitement and a little bit of decrement. But this is just to show you that this is the statistics that we have for people attending the class. It does not mean they are still not part of the cohort. It's just it just means that the attendance rate sometimes decrease with time. So another chart that I put here for you is that the lab attendance rate as well. So every one of you that are on this chart, congratulations to you. Thank you for sticking with it and for attending the labs and the lectures. It really means a lot to have you be there to listen to the class live. And so we also have all of our materials on our GitHub repository. The first 8 weeks really was about data science classes. So we have like a very nice curriculum here that goes from Python refresher up to natural language text or free text processing. And we also then began introduction to machine learning from week 8 and up to introduction to deep learning, which was week 17. So the cohort is about 17 weeks of lectures. We had 10 weeks of labs and 5 graded assignments and 1 project. Isn't this is exciting? This is incredibly compact cohort. And so kudos to you for making it up to today. And you can already go to our YouTube channel to access all of the materials. They are there, they're open source, and available for you even beyond this cohort. So without further ado, I'm going to start with introducing my colleague, Paula, to unveil the Scholars Project and introduce the agenda for the day. So thank you so much, everyone, again, and welcome to Cohort 8 Demo Day.
Thank you, Teju. Thank you, everyone, for being here. It's been a pleasure working with you and working with everyone. I'm so glad we finally made it to this point. So as part of the cohort timeline, we have students building projects in machine learning and AI, which is part of the prerequisite for them passing the cohorts. It's just a way for them to show that, okay, we've learned these things and this is how we can show that we can apply this knowledge that we've learned. Because it's one thing to just like read on machine learning and AI, and it's another thing to actually, put your hand to do the actual work. And for this cohort, we took a different route. We had people that had solo projects and we had people that did group projects. So the solo projects, hello? Okay. So the solo project allows people to, on their own, partake in projects in case they are not interested in being a group, or they would just prefer to work on their own. And we also had people in groups of 5 to 6 people, and they were able to build their group projects in the group. So we started with 14 groups and 5 solo project groups. And as of today, we have 11 group projects and 3 solo projects, which have been completed. And I think that's really amazing. All the hard work people have put into this, I think is really good. And then we also had 13 amazing mentors across, data science and AI experts in their field, people with PhDs and, master's degrees and work experience. So I think it's really been a great experience so far for the students. And, really exciting because I see the group chats and everybody's like, chatting and, I love it. So I'll just go over the agenda today. For each presentation, everyone has a time slot of 10 minutes. You can start your project. You can make your presentation within 5 minutes, and then we would have an extra 5 minutes for questions and answer at the end of each session. So we have 3 sessions today, and at the end of each session, the judges will convene to grade the projects based on criteria that we have set aside. So without much further ado, we would like to get to the first session of the presentation. We're running like 2 minutes behind time, so we'd like to get started. So we would call on Team Kwapwepwe. I don't know if I got the pronunciation right. And that will be by Sarah Akinwumi. I'm going to clap for you. Yeah, so we'll call on Sarah to present on behalf of our group. Yeah.
Sarah, you can get your
Okay.
presentation.
Hi. So let me try to share my screen.
There's video.
Yeah.
Uh,
Okay. So hi everyone. Good morning and welcome to our presentation. So I'm presenting on behalf of my team Kapwepwe, and today we are analyzing reviews of hotels and restaurants to determine customer sentiment. So our mentor was Miss Oreva Ahia, and 3 of my group members were active, including myself. So okay, let me just move on. We chose this project because okay, when we're choosing projects, I suggested something about food. I love food, and then we came together to agree on choosing projects on this project to determine customer sentiment for hotels and restaurants. Choosing restaurants and hotels generally any other sub sector of the tourism and hospitality industry is a time-consuming process because you don't know which is actually good until you check their ratings. And then some of these companies manipulate their reviews. So like this was basically to streamline that process and then make it easier for people and guests to choose restaurants and hotels that are up to par. So yeah, we set out to scrape reviews from Google and TripAdvisor, but we ended up just using TripAdvisor. Here we scraped data on 155 restaurants and 110 hotels. In total, we had more than 8,000 reviews for the restaurants and more than 10,000 reviews for the hotels. So after scraping the files, we merged them, did the normal EDA, cleaned the files to our satisfaction, and then afterwards, we originally set out to, okay, this is the EDA of the restaurants. There aren't many low rated restaurants and hotels on TripAdvisor. We had very few that were below 3.0 stars and then very many from 4.0 and above. So our data was obviously biased or skewed. And then after our EDA, we set out to build the logistic regression model and do TF idea from scratch. But then unfortunately we ran into some issues, and because we were running out of time, we ended up using the VEDA sentiment analysis package, which is already attuned to social media language. I think I'm talking too fast, but then sorry.
Fine.
Okay, so I'll just go straight to the demo because I think I've summarized everything. Yeah, our model had an accuracy score of 7.7, which I think is impressive. So yeah, onto the demo. So since we don't have many restaurants and hotels in our database, so I'll just be using some from the top of my head. For the restaurants, we had, let me just choose Domino's Pizza. I think everybody knows Domino's Pizza. I apologize. I did not catch the I was in charge of this and I didn't catch the memory, so it took a while to run. So we had about 4 different Domino's pizzas. So we made sure it returned each of each um each of them. And then for restaurants that had positive sentiments from our reader sentiment model, we recommended the place as a good place to spend their money. For restaurants that didn't have, this is one example, we recommended them trying somewhere else. And it's taking time to run. So yeah, basically we did the same thing for the hotels, and it's the same thing really. Hotel. So yeah, in all, this was a fun project to do. It took a while, but it was a fun project for us. And even though, let me just continue this. Even though we ran into some issues, like not building our model from scratch, wanted to scrape from other sites and we couldn't because we're having issues with the web scraping. And then it seemed like the reader sentiment wasn't accurately detecting the sarcasm in Nigerian English, because some of the real titles would say something like very bad restaurants, and then in the text you'll see that it's obviously sarcastic, but then the person wasn't speaking, wasn't putting negative words. So reader didn't pick those up, pick the text up as negative. And then yeah, we had some issues deploying with Streamlit, but thankfully we overcame that. There's great potential for this project. We plan to work on it even after this and try to build our own model to incorporate Nigerian pidgin, English, and slangs. And then there's also the potential for expansion into other areas in hospitality and tourism. Thank you. That would be all. Any questions?
This was a really great presentation. I really loved it. It was really good. And I could see that even when there were like bad reviews, you were recommending other restaurants. No questions from me, but I really liked this. Well done.
Thank you.
If anyone has any questions, then put it in the chat or unmute your mic. Okay. Futse has a question.
Yeah, I have a couple of questions. Okay, is someone speaking already?
Yeah.
Okay, so Futse, you can speak. I'll go after you.
Okay, thank you very much
So
for
let
this
us-
great project. I was curious to see the example you were about to show regarding the one that didn't have a good review.
Oh, okay. That was in all, we had just about 3 restaurants with bad reviews, which compared to 155, that means we had like 152 restaurants with good reviews. So yeah, this was, I don't know if my screen is still sharing. This was just one of the restaurants on top of my head where the restaurant had a bad review. So we recommended trying somewhere else. I
Okay.
think there's still potential to work on that and like maybe actually recommending similar restaurants to
Mhm.
the place.
And what if you try to put a name that doesn't exist in your database? What does
Oh,
your model says?
it tells us that it's not in our database. Let me think of it, please. Or if you can give me one from
Well, just randomly, let's say, just enter the letter O, so it's not a restaurant,
okay.
not the restaurant name, obviously. Submit. No, just O, just the
Oh,
letter O.
sorry. I'm really sorry about that.
So I think we can already start taking in more questions
Yeah,
as
you can
we
take other person.
I see Stanley's hand up. Stanley, would you like to go next?
Yeah, hi everyone. First of all, I really like the presentation. It's a good one. Um, I have a question though. So what are the classes for your project? Is it more like positive, negative?
Yes, we just focus on positive and negative, not the neutral.
Oh, okay. Then when you were scraping the data, did you like consider things like data imbalance? If there might be like more positive classes than negative?
Yes, we did, but then there was no way we could control that because TripAdvisor itself didn't have many negatively rated restaurants and hotels. So it was already imbalanced from the start.
Oh, okay. But did you like handle the data imbalance, for instance?
No, we didn't.
Oh, okay. Yeah, that's my question. But I mean, like, it's something that you should try doing, because if that's the case, then definitely accuracy won't really be the best metrics for it. Yeah.
Okay.
Okay.
Thank you.
You're welcome.
But I'm curious now, how do you handle those that had poor reviews, since those were the less that you have and your model is still capable of detecting them?
Sorry, I didn't hear that well.
How do you handle the negative reviews? Because your model is capable of detecting it, right? From the example that you
Yes.
just showed.
Yes. So what we did was negative reviews. We just tell the whoever is using our app to um try somewhere else. I'm not sure if I got that right.
No, I have not understood your response, but I think you understood my question. It was how you handled your negative labels, which was the cause of your imbalance, right? You have more good. So technically, what I would expect is that your model will only learn good restaurants, and in case where there is poor restaurant, he cannot, but yours can handle from your example that you gave. So how did you handle that? Did you program it like hard
No,
way or
the Veda package already, what it does is it goes through the sentences, that's the reviews, and then takes like the percentage of negative words, positive words, and neutral words, and then gives us a compound score based on that. Yes.
Okay. Well, thank you so much. I think Kenichi's hands up, but sadly we've run out of time. So Kenichi, if you can put your question in chat so that Sarah can get to it, and we take this offline, that would be really great. Also, Shadrach, thanks a lot. Really like that you
Okay.
everyone is excited about this, but don't let that question go unanswered. Please put it in the chat, and we can answer that. So we would go next to the next presentation now from Anoma Ungo. Once again, thank you, Sarah. You can stop sharing your screen now. Great job to your team, and thank you for
You.
presenting. So, Mofin follower Aladesoye will be presenting on behalf of the team. Please go ahead to share your screen, and you can start your presentation.
All right. Good morning, everyone. I hope you can hear me.
You're very audible. Thank you. Good morning.
All right, thank you. All right, my name is Mufin Folo Aladeshui, and I'll be representing Team Anoma Ungu on, yes, basically what we worked on our project. So we decided to go with handwritten digits recognition. And yeah, so here are my team members, Taiwo, Mokhtar, Victor, and Jedediah. Our mentor was Tayo Jabbar. Yes, so I don't know if you can see my screen. I'm trying to present, but
Your
I'm not sure
screen,
if it's
yes. Can you go to the next slide? We are seeing the first your first slide right now.
okay. All right.
Yeah, it's good. You're
Okay,
good.
so all right, so handwritten digits recognition. We decided to go with this project because it has a number of okay. All right, it has a vast number of applications, right? From postal services, enhancing security through signature recognition, and I mean it's especially um useful when it comes to the financial services, right? So sometimes we have checks, and then if you're able to scan and recognize the handwritings of people, whether it's signatures or whatnot, I mean, it plays a very important role in that industry. Yeah. So that's one of the reasons why we went with this project. And of course, it's one of the common projects, especially when you're just starting off with computer vision and image related tasks, basically. So we went with CNN, developing a CNN architecture. And the reason why we did this was because CNN is quite common, and um, well suited for capturing patterns when it comes to images. And so that is the major reason why we went with CNN architecture. Um, yes, of course, when it comes to recognizing hand digits, you have a number of challenges. First of all, there are variations in styles, and then there's the orientation of the digits, right? So these are some of the issues that we anticipated that we're going to encounter, right? But then our model was to accurately identify handwritten digits using the data sets that we're going to make use of. All right. So we were able to yes, so we're able to get a data set using the MINIS data, which is a very wide and popular data set when it comes to handwritten digits recognition. We sourced this data from Cargo, and we made use of 6,000 images, 6,000 images for our training set, and then 10,000 for our testing set. Okay, so of course, we began by cleaning data, which was pretty clean already, to be honest. And so our major work was um, actually, of course, building the model, reprocessing, and then feature extraction and all. So we started by normalizing the pixel values between 0 and 1 for faster convergence. And then because, of course, we're focusing on CNN, convolutional neural networks, so the major work was using stacking multiple convolutional layers to increase feature extraction and from the input images. Yeah. So of course, when there's an image to extract data from, then the CNN with multiple layers is able to more accurately extract those features from the images. And so that was one of the things that we did with our model. I might not be able to go through everything that is written here, but basically we're talking about the activation function that we use, which was ReLU. Also we use softmax as well. I mean, this was basically carried out by, I think, Mokhtar and Taiwo. Yes, to be honest. All right. So the convolutional layers were used to make predictions about the input digits. Our model also made use of ADAM optimizer which was chosen for its efficiency in optimizing the model's weights. And we also compiled the model using cross entropy as a loss function. Okay, so when it came to our model um, testing the model, we had an accuracy of 97.7%. Although so after we used the testing data, we decided to generate user handwritten digits by ourselves, right? So we had some of our teammates actually write from 0 to 9, of course, and then we decided to test it with our model, but we realized that it didn't perform as much as we expected, right? So out of about 9 digits, I think it only was able to accurately predict 3, which was poor, of course. And but one thing we noticed was as an issue with that was probably the app we used in generating the data. So that could have contributed to the issue. And so, of course, moving forward with this project, we don't plan to end here. We realize that we have more work to do when it comes to user-generated data, and just ensuring that we are able to extract those features, using maybe running training it more over a lot, an increased number of epochs and all that. And then we also are looking at employing, of course, we didn't have enough time to build a demo, right? Which is something that we also plan to do, like using a web app that could also scan images and then um, predict basically or recognize the digits that we are trying to predict, through our data. So those were some of the issues we encountered in building this model. But as it stands, we had an accuracy of 98.8 eventually. Although, like I mentioned, we're not able to, when it comes to generalization, we're not able to really predict using the user-generated data that we had. So we plan to still work on this project to ensure that even when it comes to the ones that we're able to generate ourselves, that it's actually able to predict as we have trained the model. So yes, I think that's it for now. I don't know if any of my teammates have anything to add, but yes,
Sadly,
thank you.
we're very out of time. Moving forward, thank you so much for your presentation. We'll take 2 questions or more, depending on the time from the judges now. Any question from the judges first, please? Okay, great. Kenichi would like to ask a question. Please go ahead. You're the only hand up for now.
Okay. Can you all hear me?
Yes.
Okay, hi. Nice project. Well done. Just a very few questions. What baselines did you consider? Like what results did you compare your results with, right? Did you have any baseline?
Okay, for the baseline, we did not really have one. Yes, we did not have a baseline to compare results with. So
Okay. Yeah.
yeah,
So I mean, this like the first project, but it's usually good practice, right? Have like a baseline. It's either even if you don't meet the baseline. I mean, this is a cost project kind of thing, right? The idea is you have something you're measuring against or trying to meet up with or surpass. Kind of gives
yeah,
you motivation to try out multiple things, right?
yeah.
Just one more question. In the beginning, you said something about signatures. Am I correct? Recognizing
Yes, yes.
signatures. Okay, so when you say signatures, do you mean like actual signatures? Like
Yes, I
maybe
mean like
signing up.
actual
Okay, so was
signatures.
that okay? So did you try that in this project, or it was just restricted to digits?
No, we just focus on digits for this particular one, but I mentioned that as something that could also be done through handwritten digit recognition. But for this one, we just focused on like normal digital
Okay.
signatures. Yeah.
Okay, so just something to, I don't know if you've thought about it, right? If you're going to identify who owns some digits or signatures rather, how would you approach such a problem? You don't need to answer it here, right? Maybe
Okay.
based off the experience you've gained through this process, right? Think about it, right? And as you're thinking about it, think about the ethics, right, related to that project. Is it ethical, right? Or is it not ethical? I don't know if you get my point, right?
Yeah.
But then again, very nice project. Well done.
Thank you so much,
Thank you.
Kenichi. This is a very, very insightful feedback. We'll take a question from Stanley next.
Let's Nikon go since I've asked the question before, maybe after him.
Sorry.
Okay, okay. Thanks, Tali. Okay, great presentation. And well, I know this is pretty common. These projects, which is fine, and you trying to extend the usability is also okay. But I'm thinking that since you tried it on real life experience and in your own tests, you only could capture just 3 digits. Another contribution might also be you introducing more of those data sets into it so that the data sets could be a little bit um, more robust to be able to identify different types of figures. That's what I'm thinking. So it's not just you being able to identify alone, but one of the shortcomings you've been able to see here is that it can't really identify if real life people start to like put in numbers and stuff. So your own contribution itself could also be adding to those data sets so that real life experience can be used and you can actually determine more identifications through that. So that's another approach I think you could look into. But good job.
Thank you so much. I appreciate it.
Well,
Thank
thank
you.
you so much for all of his very nice and kind feedback. And I hope that the team would go back to use it to extend the project if they wish. Next, we will go to the presentation from Team Bogiba by Ariyo Monsurat. Again, a virtual round of applause to Team Anoma Ungu. Thank you so much for your presentation. Bogiba, are you ready? You can take it away.
Yeah, good morning.
Good morning. Please proceed to share your screen and start your presentation.
Can you see my screen?
Yes.
So I'm Mario Monserrat Abisola.
Before you start, Monserrat, can you make your screen expanded, make it full screen
okay.
in presentation mode?
How
Yes,
about now?
great. This is great. This is great. Kick it off.
Good morning, everyone. I'm Mario Monserrat. I'm representing my team, Baguba team. So we worked, and our mentor is Fortune Adekuba. Yeah, and my team members, Caleb and others. They're actually not around today. So we worked on medical frequent. We asked questions, but yeah. So the reason why we delved into it was because of the decreasing of doctor-patient ratio in Nigeria, leading to the overburdened healthcare provider, resulting to inadequate access to accurate information. So the time taken to see doctors and all, since there is no enough doctors, and many of the doctors are leaving the countries, our country rather. So that's how we delved into this. So we thought maybe the solution is for us is to create a medical FAQ bot that provides the public with answer to medical questions to relieve overburden healthcare and delay patients. So there are some things that you really need to ask that does not really require you to see the doctor first. Like maybe you're having a headache or something, you can just know, okay, maybe the bot will give you an answer that you need to rest and everything. So when you rest, then when you don't feel fine, then you then go to see a doctor. So that will reduce the queue in the hospital. So that's why we delved into this. So that was our solution. And we got our data set from here. We reviewed our data set. We made sure that it's in line with the project requirement. Yeah. And some were giving prescriptions, which we don't want that because we don't want to give false solutions. So we didn't pick all those data sets and we cleaned it, and they were in different columns. The question and the answer pair we made sure that we pick the question and answer pair column data sets, and they were in different columns. We merged them together and we combined all the data sets together before we use them. So, and the modeling approaches that we use, we tried using GPT-2, SLN, BERT, and Facebook RAG token models, OpenAI. But the one that really worked, that we really tried, was the GPT-2 that we used for this solution. Yes, that was what wasn't giving us issues that we could use, so we used that. Then this was the result that we got from our training when we trained it. Got this result, the question that we asked it, and the result that it gave to us to see if it's aligned with what's supposed to produce for us. So this was what it gave us. So what are some effective techniques of managing anxiety and stress level? So it gives us the solutions to it, like you get enough sleep and hydrate your body through the day. So something like that. So it was able to train and give us this. So we trained for like um so we trained for like 5 hours 30 minutes. We couldn't do a lot of training because of um time that it consumed in training, and the computational resource that is needed for the training as well was a limitation, so we couldn't train for long. So this was the result that we got from the training. So like I said, for the retouching limitations, insufficient data, there was no insufficient data. We cannot have enough of data. It's not possible for us to have all the data that we need for it. So there is insufficient data, insufficient computational resource, like I said before. Then we need to learn other things too for us to be able to do this. And almost at the end of this project, so for like few weeks now, members are not available. They were really engaged, and so like I said before, there was not enough time for us to experiment because of the time we used in trying other models before we settled for this. Yeah, so we're able to train our model and we got results. So that's it from here. Hello, can you hear me?
Yeah, we can hear you. So this is really good so far. I saw that you had a lot of complaints about data sets. I guess, yeah, it's truly you can't have enough data, but you would have like sufficient data, at least to a very good extent. But
Yeah.
really good job. If anyone has any questions from the audience or the judges, you can raise your hands or you can just unmute your mic. Kinechi, go ahead.
Sorry, I'm always having questions. Okay, hi. Very, very nice project, right? I can imagine how stressful it would have been. But one thing I'm very curious about, right, is
Please, I can't hear you very well.
can you hear me? Can you hear me? Is it better now?
I hear
Can you
you.
hear me?
Kind of
Okay.
sounds like you're far away from your mic.
Yeah.
Okay, I think it's this AirPods. Just give me 1 second.
How about now?
It's better now.
Okay, cool. Okay, so now considering this is like medical data, right? Two questions. I know the medical field is quite controlled, regulated, right? One question I have, the data set you use, right? I
Hear
mean, I know this
you.
is just some small project, but did you consider if those data sets um are um responses or approved responses to some kind of illnesses and the rest, right?
I'm
That's
sorry, I
one
can't
question.
hear you.
Oh, my. It- Can you hear me now? Is it better? Hello.
Yes.
Yes, I can hear you.
Please continue to talk. I won't be able to hear you again.
Okay, so I'm saying since this is some medical data, right?
Yes.
And I know the medical field is quite regulated. The first question is, those data sets you used, do you are they kind of approved for such use, right? Like the responses, are they responses that are approved? That's one question. The second question I have is, how did you manage context, right? When you trained or pre-trained your data set on Birth and GPT, the ones you listed out there, how did you control context? How did you ensure that your bot does not go out of context, right? Yeah, those are just the two questions I have.
Thank you. So we got data from organ phase and cargo, which we realized that it was starred as a great one to use. So we didn't consider that part that we were talking if it was actually approved or not. But when we realized that many people have used the data, so we considered using it. That's what happened. Then for the second one, we are still training, to be honest. We are still training. We just tried and trained this one. So we didn't train for long, so I cannot really talk about that part. Yes, we didn't train for long. Yeah.
Yeah, I mean, it's totally fine. I think the point of the questions is so that you start thinking about the future
Yes,
where you want to
yes,
push these
yes.
things out, right?
We have the intention of going back to it and train it and see how
Yeah.
it trains and actually add um more features to things like expand it better
Yeah.
than it is. So yeah.
Yeah, cool. Great job, guys.
Yeah. Yeah, thank you so much, Montserrat. I just want to say great job to the team. Many of the tools that you've used in this project are not things that you were exposed to within this cohort necessarily. So I'm pretty sure that you did a lot more learning to get yourself familiar with this. So I just want to say kudos for going outside of like some of the content that was covered, and for trying to explore the world and the realm of the planning. And I hope that you can take a lot of this feedback as something that you already can think about if you want to pursue like these projects in the future. So again, please everyone give Montserrat and a team
Thank
a
you very
virtual
much,
round.
Sergio.
And we would, without further ado, now move to our next presenter, Funbi Bolarewa from Team Selassie. Do we have Funbi on the call? I cannot Is anyone from Team Selassie on the call? Okay. It seems we are missing Team Selassie. All right. This is interesting. This means that we even have more time to talk, to discuss or to ask more questions. So while we try to find Team Selassie, if we would have them on for this presentation, we can have more questions if anyone has questions for Bugiba. Otherwise, like we will start our last presentation for this session in the next 2 to 3 minutes, if there are no questions. Any further question? Okay, Futse, please go ahead.
Thank you. Thank you for your good project. I was wondering if while working on this project, did you go come in contact with someone of the medical field to seek advice maybe on what are the risky things your model is capable of doing so that you kind of handle it in the back end, like kind of controlling some kind of questions that someone could ask, or the context also of the person that is asking. And in your example, please come a bit on the example that you showed on your slide. The test you showed on your slide. Can you hear me? Can you hear me?
Yeah, I can hear you,
I can
Monserrat.
hear you.
Okay. No,
I
I
think
was
she's
just wondering
muted.
if she was hearing me saying that she should go on the slide.
I
I
think
think
she's
she's
trying to go
muted.
to that. Oh, yeah, Monserrat, you're muted in case you're trying to talk. It's maybe a technical glitch, maybe. Okay.
I'm not
All
trying
right.
to say anything, please.
Oh, great. Can you go to the example you
Did
had on your slide then? The example you showed us. Futse has a
you hear
question.
my questions?
Hello?
Yeah, did you hear my questions?
No, please.
Okay. Please come to the example you showed to us. And while you're going to that, I was wondering if during this work, did you go and seek advice from people of the medical field to help you trying of control what your model is capable to give as answer, so that in sensitive cases, how should your model behave, and stuff like that. And so in the example that you gave,
Hold on, please. Um, we thought about that.
you were on the
Since
slide. Why did you
yes,
leave? Please
you
come
want me
back.
to show you the hello?
Okay. I think we would
I
have
think
to
I
take.
want me to show you my results.
I think we may have to take this offline because sadly
Okay.
now we are running out of time. And so we need to start our next presentation. Again, thank you so much for your presentation. Monsura, please respond via chat. Let's take this offline and continue the great discussion there. So our last presenter for this session is from Team Solo Ransom Kuti. This is my mentee, so I'm very very excited to hear him present his work. Samuel Oyeneye will be presenting next. Mofi follower, please. You can stop sharing your screen so that Samuel can share his screen. All right. think
Happy
I
New
will stop it myself. Great. Samuel, you can go ahead to share your screen.
Okay. Sorry, can you give me like 3 minutes set up my my phone till not
Samuel,
responding,
are you
sorry.
trying to present right now using your phone? This is next level.
I'll just brought the light now. Please, just
I can barely hear you. Your internet is not great right now. Can you hear me? No. Samuel? Okay. I think
sorry. Yeah,
Samuel is
can you give me 2 minutes to use my laptop? Just brought the light right now.
okay. Well, Godspeed. We'll wait for 2 more minutes. All right. So while we wait for Samuel, up Nepa. While we wait for Samuel to bring the light. Sorry, I said to bring the light to start his screen sharing. I just wanted to again congratulate every one of you that have presented so far for the amazing work done. I'm really glad to see that you got your project up to this point. Great job, really. I hope that in the process you have learned more about like the lectures and the labs that we introduced you to this cohort, and then I hope that this has been a very good experience for you to solidify your knowledge in machine learning, data science, or deep learning concepts if you're doing projects related to deep learning. So Samuel, is it time to do that now? Are you able to start screen sharing? Okay. That's the group name, Ransom Kuti. Oh my God. Fute is asking if someone is fella. No. I hope not. Like he's alive. So so it's the name of the team. It's named after Fumilayo Ransom Kuti, not Fela Kuti. The amazing Fumilayo Ransom Kuti. Okay. Sadly, like Samuel, we can only wait for a few more minutes. Otherwise, the judges would have to convene to chat about the first session, and that means you would not be presenting, which is sad because Samuel presented to me yesterday evening, and he did such a good job. I thought it would be nice to share his projects with the team today. So I do know that he has everything ready. Okay, so I've just been informed by my colleague that I can present in the next session. Okay, great. We will now convene. Right, this is 12 o'clock, and so let's take an 8-minute break with the judges to talk about this first session, and in the next session we can have Samuel present first, and we continue with our program for the day. Thanks, everyone. We'll be back in 8 minutes. Let's take a short break.
Sorry, Teji, you're muted. Hello, Teji. You're muted, please. You're muted.
Muted. Someone else is.
Oh, was someone talking? I couldn't hear any other person.
Hi everyone. Thanks for waiting. We should be starting the next presentations in a few minutes or just 1 minute, to be honest. And the next group that we'll be presenting is Team Matai. by Oyelayo Sheye. So Sheye, please get ready in like 2 minutes. So we'll start. Samuel, I don't know if you still like.
One needs to.
Huh?
Sorry. Hi, Fola.
Hello? Yeah, I can hear you.
Can you pause for like 2 minutes so that we have like a summary from the judge? Because we were just discussing in another meeting room just to summarize this session.
Okay.
And as soon as like we'll have someone come back to give a very short summary, and then we can start the next session.
Okay.
Okay, we are back, and sorry for the miscommunication. We had a quick chat with the judges. So it seems like my business was out in the open while I was gone. Thank you for catching that and for letting me know. So before we start the next session, I'm going to invite my colleague Kenichi to just summarize the judges' feeling for the first session, and then we can proceed to the second session as Fola has just announced.
Okay. Hi everyone. I hope you all can hear me now. Can you hear me clearly? Okay,
Yes.
cool.
Yes, please.
Yeah, so very, very nice project, everyone, right? To be honest, I'm impressed because, like I had said, even to the first team, you rarely see people get to the end, right? And you hardly find people do complex projects, right? I'm looking at the project. Some of them are obviously complex, but you guys were able to get your hands dirty with these various things. And so kudos to you all, right? However, there are some observations that we want to put out there that we believe will help you even after this cohort, right? It has ended, will help you in your career as a machine learning or deep learning engineer, right? One of the things we observed, right, is, or I think I'll just, instead of saying observations, it's just going to be recommendations, right? One of the things we advise is that you spend a bit more time on the core concepts of machine learning, just as you were taught in during the cohort, right? It's beautiful to jump to very complex algorithms, but one thing you should understand is that before these complex algorithms or complex solutions came to be, right, there were some foundational thinking or thought process, some very basic models that were built that kind of underscore the essence of some patterns in machine learning. It would be nice if you start small, right, and gradually build up to these very complex solutions so that you don't miss out on every other concept, right, that are important as an engineer. Another thing that we kind of noticed is, see, when the reality is that every of the projects that have been presented here can go out as a solution in the market. As a matter of fact, I'll be one of the first people that will buy your solution when it goes live, right? But while you're thinking, you also have to think about the ethics of the process that you have put into place. Ensure that there will be no ethical backslash on you or on the methods that you have employed for your solution, right? These are the observations that we kind of notice, and I would really be happy if you guys can take into account these observations and put your solution out there so that I can buy it. Okay. But kudos, guys. Thank you.
Well, thank you so much for that feedback and like a general outlook. Really appreciate it. So next we'll go to Team Mataya, who is being represented by Oyelayo Sheye.
Good afternoon. Good afternoon. Can we hear?
Yes,
Okay.
please.
So I don't know if my screen is visible.
Yeah, your screen is visible, but you should put it in presentation mode. Now we are seeing something else. We are seeing your Excel sheet.
What about now? Is it perfect?
Yeah, we see your slides. Can you put it in presentation mode?
Okay. I think it's okay now.
Yes. Is this the beginning?
Okay, yeah. Yeah, good afternoon, everyone. My name is Sheye Oyelayo, and representing Team Matea. So we work on customer churn prediction. So I'll be introducing my team members. Oyelayo Sheye, that's me. Jack, Oraru, Adenike, Ayuluwa, Jisuni, and Messiah. Okay. Okay, so what's motivated us? So we are trying to address one of the dimensions used in measuring growth for organization, customer retention. And our aim is to use machine learning to predict customer churn prediction, the metric used for gauging customer retention. In order to address this issue, we obtain our dataset from Cargo. Okay, these are some of the insights we uncover from the data. Age group distribution, we can see that adults, we actually have much adults comparing to okay. So our data was pretty neat. So the only thing we did was to just rename some columns in our data that are long. So then we work on removal of outliers. So then we did rescaling and normalization. So we did encoding also because we have some categorical data such as gender. We use label encoder for categorical data encoding, and we use ordinal encoder for ordinal data. So our data set was heavily imbalance as we have existing customer class approximately 5% higher than the attributed customer class. So in order to address this, we carried out oversampling techniques using smooths. Then we move to feature selection. So the purpose of feature selection is to ensure that we get rid of features that are not contributing to our target variable, and also to get rid of features that are actually contributing the same way to our target variable. So these are the important features. So okay, these are the some of the things that we actually address with our project. Multicollinearity. So is a statistical phenomenon that occur when two or more independent variables in a regression model are highly correlated. So this is when we have two features or more than one features that are actually contributing the same way. So we get rid of them and retain one. So then we make use of recursive features elimination also to select the most important features for our model. So we use k-fold cross validation. So and we had an accuracy of 95% with standard deviation of 0.07. We actually tested different models. Then we selected the one that actually gave us the best results, and that is random forest classifier. So that is on our validation test. Then on our test set, we had an accuracy of 85% using the same random forest classifier with only 6 important features. So additionally, we obtained 77% accuracy using rich classifier also. Okay, so for the deployment, we did kind of hybrid model. Together, random forest classifier and rich classifier, so that they can leverage on each other's strengths. So then we deployed our model using streamlets. Okay, so we'll be moving to the next slide, which is application demonstration. So okay, so this is our application. So this application is capable of predicting customer churn. So based on the parameters that we have here, so we can actually input any value here, and the application is going to make the prediction for us. So am I not able to input the right, but nevertheless, it's still going to make the prediction. Okay. Okay, so these are the other parameters. Okay. So we can see the prediction. So and if we input other values, so it might predict that the customer is not on the verge of journey. So, but I don't have that value offhand. And we not only predict for single individual, so we try to address the issue of if someone wants to predict for thousands of customers, and how do we go about that? Are we going to be inputting their values one after the other? So we see that will not be easy. Then we try to also work on many individual also. So on many individual, so this one gives us the ability to upload a CSV file. So, and before I upload that, let me try to show us the. So can we still see my screen?
Yes, we can.
Hello. Okay. Yeah, so this is the CSV file I'm trying to upload. I think I have about I think more than 200 samples, if not more than that. Oh, it's actually much. Okay, so I'm going to upload this now, and application is going to make that prediction. So so I can download the predicted results now. Can we see? So we can compare the value. So you can see that most of this prediction are right. So you can just compare them. So another thing we been emphasizing on is we make use of two algorithms so that they can leverage on each other strengths. So it's not only one algorithm that is actually making this prediction. So random forest classifier and rich classifier. So these are the two algorithms that we incorporated together to make all this prediction based on their importance of their features importance. Okay. I'm done.
Yeah, well done. That was really good. I can see that you got most of your predictions right. And I really like the what's it called? The user interface that you built. That was really nicely done. Well done to your team. Okay, Kenichi has a question. So he is asking how you considered the customer journey when deploying to Streamlit. And also, he's also asking, when you say you're using two algorithms together, what do you mean? And how does it work? Are you doing some sort of averaging? So I don't know if you want to answer that now. I think you should if you can. Hello?
Okay. Yeah, I'm with you. So let me start from the second question. I think the first question I really get that first.
Okay.
So okay, so for incorporating the two algorithms, yeah, it's kind of averaging. But then these two algorithms, they actually have 6 features that are most important to their prediction, but then they have 3 in common. So altogether, they are a mix of 9 features, sharing them together. So what actually now happens is that they are making these predictions separately. So as random forest classifier is making its prediction, rich classifier also is making its prediction, then we now did average. So the first question.
It wasn't a question, sorry, it was a compliment. I read that wrong.
Okay.
Femi also has a question. Femi, can you please unmute your mic?
Okay, thank you. Really good presentation. I think from start to finish. I think I like the fact that there was the option to score multiple customers, because if this was deployed in an environment where they have to use it, having to score just like a single customer every time might be a little bit stressful. So I think the bulk scoring actually makes a lot of sense. Another just one comment is the evaluation metric. So I saw that you used accuracy. I guess maybe depending on the percentage by which you upsample your minority class. If there's still like some sort of imbalance, accuracy might not reflect performance accurately. So yeah,
Okay.
that's the comment I have. So yeah.
Thank you so much, Remy. Khadija has a question. Please, can you unmute your mic?
Yes, can you hear me?
Yeah, we can.
Okay, so I just wanted to, I liked your presentation. It was really cool to see. But I just wanted to ask, like, did you consider like the end user's perspective, like people that have no coding background, and this would actually be really useful to them? Maybe did you consider making things like quite simple, like maybe just when you upload a CSV file, you see the percentage of their customers that are like going to be lost and the percentage that they still have, we should make them make quick decisions, like instead of like maybe following customer, like following individual customers, which are actually good. But I'm just asking, did you consider like the end use of it, maybe the ease of use of the streamlined application and all of those things?
No, actually, well, I think it's something that we work on that after this.
Thank you so much for questions. Thank you, team, for your presentation. So we will be moving on to the next group, which is, sorry, I just need to get the, so I think it's, sorry.
So Team Mandela will present next.
Yeah, Mandela.
Representing Abdul Latif. Asafa, you can start sharing your screen now.
Okay. Good afternoon, everyone. Can you see my screen?
It's still loading, but yes, good. Oh, that looks
Okay.
pretty.
Am I audible enough?
Yeah.
Okay. Good afternoon, everyone. My name is Ashafa Abdulatif, a member of Team Mandela. And for today, I'll be presenting about air quality monitoring and anomaly detection system. And our team was mentored by Joshua Coopers, and my team members are Damilola, Yetunde, Peter, myself, and Oluwapoloro. So, and the five of us were active in participation of this project. So, the aim of this project is to design a model that would help predict the air quality index and monitor the air in Nigeria using values from the states. And today we know that with the way urbanization is happening, there's a rise in the state of air, and it is one thing that the world is trying to reduce, going by the COP28, COP28 conference, where the world is trying to be energy free and also make sure that our world is pollution free as much as possible. So this project will allow us to predict the air quality index using parameters like the latitude and longitude, the specific date, and then some values. Okay. So for the exploratory data analysis, we sourced the data for the 36 states from the Open Weather website using their air pollution API. Even though some of the data was not enough, but we were able to scrape the one we could use, and then from there we converted it from the JSON file into a CSV file so that we'll be able to use pandas to handle the description and other exploratory data analysis methodologies. And using our data set, we discovered that the major pollutants are CO, NO, NO2, O3, SO2, PM2.5, PM10, and NH3, which are major parameters in predicting our air quality index. And in considering the final values, we graded the AQI using standard 5 to 1. So if it is 1, it is very, very good and very good, and if it is 5 means it is poor. So which has been shown in the picture before. And it should be noted that PM means particulate matter. Also, for our modeling, we use the gradient boosting regressor for single AQI value prediction, and then we use the multi-output regressor for multiple target prediction. For the evaluation matrix, since it's a prediction model, we use them MSC and MAE and the R squared metrics to determine which of them is the best. And then these are explanations about the models and how we came about them. And then for the solution deployment, we use them Streamlit to deploy an application, which is below, which I'll be testing to ensure that to show how our model works. So can't see my other screen. I think I would stop sharing and share back. I can't see my other screen, that's one.
Okay.
Okay. So can you see my screen now?
Not yet. I think it's still loading. Okay, we can see it now.
Okay, so this is our AQI predictor. We called it a Mandela Air Guard. And the application is used to predict the air quality index for states in Nigeria. So on this sidebar, we can see the values that we are using for our prediction. So we have the longitude, latitude, the date, and then the state name. So we also show the table here so that it would assist in the values we put in here. So if you want a state like maybe Bauchi or Delta, let's say we choose Borno. So we have our longitude at 13.8, so 13.3. And then for the longitude that's 12.18, 12.18. And then let's say we choose today's date. Then we choose make predictions. So, okay, so yes. So
you
this
put the
is
wrong or the latitude and longitude.
okay. Sorry. The state was
Borno.
Borno. Thank you. Okay, so after putting it, we can see that the AQI value is 4.9, which shows that it's bad using the range I said before, and then these are the pollutants, the major pollutants that affected the prediction. And also here we can see a little map here that shows representing what we have here down here on the map to give us better pictorial evaluation of our model. So that's how our model works. And for further, so for the challenges encountered, we had issues with the data collection because we observed that our data was a bit skewed, and I think it was not enough for. So I think if we had a better database, we would that will help us improve our model. And also for the metric, I think we had issues selecting which one was the appropriate because of our skewed data set, we had some imbalances in some values. But before we now decided to settle with the multi-output regressor. And then for future directions, we plan on improving the models and then getting better data sets that might not limit it to only Nigeria, might limit it that can expand the project to Africa and even the world, to just put in the values and check the AQL index for states or any city in the world. And also we also plan to work on the anomaly, to detect if there will be any anomaly in the air, and will then give us like a trigger warning to the to the person in charge to know what caused the anomaly. So that is basically our project.
Thank you so much. This was a really good presentation and project that you've done. There are already lots of questions, like everyone is excited to ask you questions. So I don't know if, okay, there's some questions in the chat that we could start with, and then we'll go to people that want to, unmute their mic. So the first question is, what is the range of a good AQI? Also, by the way, if you have your team members here, it doesn't necessarily have to be the person presenting to answer the question. If you have like your team members that could answer the question, you just need
Okay,
to.
I put in a range. So sorry for the first question. I don't think they are here. But I put in a range like for I think it's on my slide. For 1, it means that it's ranging from 1 to 5. So 1 means that the air quality is good, and then 5 means it is very, very bad.
Okay.
So that is, yes. So, and then 3 is moderate. 3 means it's moderate. Okay.
Okay. Maybe we should go to one of the raised hands. Tayo, would you like to unmute your mic? And then we'll go back to the chat questions. So we'll just alternate.
All right. Thanks, Fola. Sorry, please, could you put up your screen again? Where on the Streamlit, just the last screen that you're displaying. It's kind of a follow-up question on Teju's, because yes, you've answered the part of my question, which is what's the range for the AQI, but from the results there, I just want to confirm that there's an AQI value being printed, and also given all of the other indicators that were predicted. Okay, so the AQI is the first point. That's good. But regardless, if I were someone who doesn't have any context as to what we're doing here, and yes, I know that the AQI value is 4.9, but then I see the other quantities being displayed, CO, such as carbon monoxide or
Yes,
nitrogen oxide, and the rest of them.
Nitrogen dioxide. Yes.
Yeah, so how exactly am I, as a novice, without prior background knowledge, how do I explain or how do I interpret all of these other quantities that are there? Does that make sense? I mean, I don't expect that you'd have the full answer to what I am saying, but I'm just saying it will be better to be able to indicate that, okay, the AQI is, which is what we're looking for, and then
Yes.
maybe further quantities. That should become a matter of interest to someone who wants to see how it's broken down
Okay,
or
now,
how
okay.
everything combines to come to the AQI value.
Okay, thank you. Okay, concerning the indicators, I think because I just used one example, this bar it changes with the color, so that's why. So if it is like with the 2 or 1 within that range, changes to a yellow color. I don't know if I have time to demo that. So it changes to other colors if it depending on how good the air quality is or how good our prediction is. So there's an indicator for that. If you change the values and the dates, it didn't confirm the date.
So we don't have a lot of time now. I would encourage
Yes.
Kenichi and Fortune to
So
please put their questions in chat so that you can get to it. Thank you so much for your presentation and for your demo. This is really good. And yeah, there's still some work I think that we need to do on the presentation. And I think I will have a chat with your mentor or even we chat afterwards to see how we can make it more user friendly. Just like Tayo said, as a layman, I don't know what this means, and you're trying to teach me that I care about it. So it would be nice to have some description or something that I can check to be able to understand. So these are some work that we can do, a little bit of work to make this much more user friendly, I think. So thank you again. A virtual round of applause to you, Abdul Latif Asafar. Thanks for presenting. And next we will go to Samuel Oyeneye's presentation. He had a technical glitch, but he has confirmed that he's now ready to present. So Samuel, you can start sharing your screen. If not, ready? No.
I can't present. I can't share my screen.
You have been made a co-host on this.
What's the screen sharing?
Are
It's not allowing.
Okay, maybe it seems like you have more than one of you on this call, which may have caused the confusion. So let's try to see if we can get that resolved very quickly. Because I've
Teju,
made
can you share the presentation so someone else that's on laptop could actually do the presentation? Can I just talk over it?
No, it's fine. You should be able to do that now. Thanks a lot, Leko, for the suggestion. Sam, I'll try one more time. Otherwise, we would have to circle back to you again.
Can anyone
Yes,
see my screen?
sadly not yet. It's black. So okay, yeah, now it's coming up. So you can start your screen share.
Okay. So
it's still loading on our side. Hopefully everything works well in time. Otherwise, we may need to come back to you while we try to fix this glitch. Okay, some of this is still loading and we don't have a lot of time. Why don't we come back and you try to see if it's the Wi-Fi that is causing this? that
Okay.
okay?
It's actually showing here, but no problem. Yeah, that's cool.
Okay, I will ping you. We'll try to fix it background. All right, so next we'll have John Tinsalif. Dolamu Oludare will be presenting on behalf of the team. Dolamu, please share your screen and take it off.
I'm trying to. I see my screen now. Sorry.
Yes, I can. Please put it in presentation mode. Thank you.
Yeah, so good afternoon, everyone. My name is Olam Oludare, and I'm presenting on behalf of Johnson Stanley. I worked on a machine learning approach to diabetic risk. So this is my team members. Like we're mentored by Olawale Abimbola, and I also have like Femi Akinode, Usman Daudi, Brian Obluri, and Stanley Guazo as my team members. So in production, like our work like circle around diabetes, which is like a major disease, like a major health concern, especially the World Health Organization. And this is caused by insulin. Insulin is an hormone that's produced by the body to manage like sugar levels, to manage body energy storage in the body. And it also helps to like keep the blood sugar in a healthy range by facilitating glucose into the body. So one of like the major issues that we think are problems with like it is in 2019, diabetes and kidney disease, they led to approximately like 2 million deaths, and there's been like 300% diabetes related in 2000 and 2019. So like that drove like the question, what if because it's possible, what if like diabetes could be detected early? Because diabetes actually leads to like complications if it's not detected early. Complications like heart disease, cardiovascular disease. So um so the question that drove like the project was, what if diabetes could be detected early at an infancy level? Like this could actually like reduce cases of death related to diabetes and also complications from this particular disease. And also it could reduce workload on the hands of a medical professional in terms of possibly someone comes to do a checkup, like to examine, possibly he has like a diabetes, he's prone to having diabetics. They could actually like use, of course, they have like other important matters to attend to. They could have an emergency. So this is like a potential solution to like reduce workload of medical professionals. So, like the project entails like the project immediately to show that diabetes related data generated in medical field is actionable by employing the power of data and technology to develop algorithms that can help predict and detect development of diabetes in the body at an early stage. So what we plan on doing, like we plan on accurately identifying individuals at high risk of developing diabetes based on the combination of their clinical, genetic, environmental, and lifestyle factors. And also, most importantly, like early detection and prevention of the disease, and also efficient resource allocation and continuous learning and improvement, because like there would always be continual generation of data with respect to this problem. So it could lead to insights and more improvements with respect to this issue. So this is the framework for our project. So like we got our original data, we processed it, and we built a machine learning algorithm. Then we also built like a full-fledged web application that allows user to interact with it and also like get predictions from their user data. Source from Kano. We had issues getting data, but we finally got data relating to diabetics issue on cargo. So our data set had like 10,000 records. That's 10,000 rows, and it had like 8 features, which includes gender, and biological sex of the individual, their age, hypertension, like if they've had hypertension before or if they haven't. Like so it was represent like 0 stands for no hypertension and 1 stands for hypertension. And also like the record of heart disease if they've had heart disease before, and smoking history if they've ever had like if they've been in contact with smoking or they, they were smoking initially before and they stopped. So we had like 5 categories for this. And also BMI. Like BMI is used to measure the body fat based on your weight and height of the body. And also like hemoglobin levels, which measures like a person's average blood sugar level over the past 3 months. And also blood glucose level, and finally like the target column, which is like diabetes, which predicts if the person has diabetes or not. So this is like a bit of inferential statistics we carried out on the data sets. We did not have any missing values on the data. So like from the inferential statistics, like the age, you could say like there was no like the most of the columns were normally distributed because the mean of each of the columns was a bit close to the median. And okay, the mean age for the data was 41 years old, and the maximum age on data sets was 80 years old. So it was between 0 to 80 years old, like or 1 to 80 years old. The age range was between 1 to 80 years old. So for the data set, we carried out processing function to like clean our data. So we noticed that we had like 2 columns that were categorical in nature. So that's like the gender and the smoking history. So we had to convert them. We had to encode them rather to numerical values. And we also had like some data types that were not configured correctly. So we use like these preprocessing functions to like transform them. So after transforming, we had like all numeric data sets. And like this is like few of like the explanation that we did on data set. You can see like correlation heat map between all the features, and also like age group respect like the proportion of individuals with diabetes with respect to like age group, and also like distribution of diabetes across gender. Like there was also imbalance. There was an imbalance with respect to like the people that had diabetes and did not have diabetes, and also like the gender. Also, we had like a bit of imbalance data sets. And you can notice that most of like for the BMI, we had like a lot of obese, a lot of patients were more obese. And with respect to smoking history, like a lot of the patients were former smokers. So like for our model building, like this, we put our model building, we carried out data splitting, standardization, cross-validation, and we also carried out some hyperparameter tuning. And finally, we evaluated our models. So the models used for our project was linear regression and polynomial regression models to increase the complexity of our model. We also like made use of random forest models and XGBoost model. So like from our model building, like this were our results. For the linear, we can see the confusion matrix for like each of the models. For our linear regression model, we carried out cross-validation on like the trained data sets, and we found like the average of like a 5-fold cross-validation. We found the average of the data set, and we also like used like standard deviation to gauge the difference between each of the values we got to know how disparate they are from each other. So for like the linear regression, we had like an F1 score of 73%, while for the test set we had 72%. And for the random forest, we had for the cross validation set, we had an F1 score of 79%. You can see that we have like a very low standard deviation, which means that like the values we got for the F1 scores for the five-fold cross validation, they were close to each other. And for the test sets, we had 90.3%. And for the SG boost model, for the cross validation set, we got an F1 score of 80.59%. And for the when we tested like new data sets on the model, we had 80.47%. So from like we can also like you can see the confusion matrix too. We can see we did not use like accuracy to like evaluate our model, because I feel like accuracy is a bit biased on the model, because it doesn't really tell the full picture of how the model performs. So we went with using F1 score as our metric, evaluation metric. So like for our solution presentation, so we built a full application that embeds our machine learning algorithm and makes it interactive for the user. So what happens, like the user provides their clinical data to the web interface, like the web application. Then the web application sends like the data to an API that adopts the machine learning model. So the machine learning model like predicts data based on the data set that was provided by the user. Then it then returns a prediction back to the web application for the user to interact with. So I'll just show the live demo now. Maybe a bit. I have to. Can I like show it again, because I might not be able to see browser. Hello.
Yes, please feel free, but you have to know that you only have about 1 minute or so.
All right.
You can stop sharing and share again if you want to present something like. Okay.
Okay. Sorry. Okay, I'll just share now. Okay, so like this is like the web application. Can you see my screen? Sorry.
Yes, I can. Yes.
Okay. So this is like
Please.
the application we built for project. So for the user to use, we just you provide your name. So I can just provide sorry. Let me just use that. Email. So you have to provide like if you have ever been diagnosed with hypertension. So I'll just choose yes. Have you ever been diagnosed with any heart disease? Yes. Yes. Diabetes. Have you ever been diagnosed with yes? No. So I can just pick next. Then you have to provide like the smoking history. Let me pick former. For this I'll pick first. So once the user has provided the data, you can actually send. This might actually take a while. So it actually like gives you information about prediction. So this says you are not at the risk of having that, but it's based on the data that the user provided. So
Thank you so
like
much for your demo presentation, Dolamo. I have a quick question, then we have maybe one more question First of all, why do you need to collect personal details to be able to use your app? Because imagine a lot of these conditions are very personal, and then if you provide a solution and you want me to put my details, how am I to know that you will not end up linking those predictions to me in the future? I don't want that. I don't want you to know anything about me, but I want you to use your app to see if I have diabetes or not. So my question is, why do I need to put in my email address, my full name, I guess the gender, you may need that, which is okay, maybe. But my full name and my email address, why do you need that?
Okay. There could be like a possibility of sending like the result to the user. So you could send like the result to the result to like the user's email. I don't know if
Yeah.
that's
This makes,
so.
I understand that. It also can be a marketing scheme. You can then continue to collect my data and send me things I did not ask for. But I suppose that you should use that. This should be optional. If the user want to, you would mention that we can send you this result if you would like some more details about something that we found out about people like you that have this condition. But for that, we need your email address or something like that. So I'm just saying personal information should always be optional. If you are collecting it at all, and you have to specify the reason and for how long you're collecting it for. Anyway, this was just a very quick comment. Thank you so much for your presentation. This is great. This is great work, by the way, if I did not say that before. So do we have any question? Maybe we can take one more question before we move to the last presentation for this session. Okay. Lekon has his hand raised. Please go ahead, Lekon.
And so I just want to find out. So I think we have like two types of diabetes. We have the type 1, type 2, the one that is hereditary, and the one that is by your habits. So does this actually predict both, or is it just one based on habit that this predicts?
Sorry, I didn't get the question.
Okay, so I'm saying that like there are like two types of diabetes. You have the one that is hereditary, and you have the one based on your lifestyle. And I just want to find out, does this cover both, or is it just one type that this covers?
I think it covers both based on like the pictures that we used to train the data. Hello.
Okay, so I think we can move the rest of the question offline. If Leko is not satisfied with that answer, you can provide further context, and Dolamu can try to answer your question. So our last presentation for this session is by another solo team member. His name is Ladipo Ikpadiola, and I'm excited to hear about his project. Ladipo, please take it away. You can start your presentation now. Ladipo, are you ready? You mentioned that you were ready just a couple of minutes back. But is everything okay? Not sure right now. Okay. You cannot escape technical glitches, I suppose. Can you hear me, Ladipo? Can you please try again? Thank you. Okay, great. So yeah, please, you can start. We cannot hear you though. Are you saying something? Perhaps you're still muted. You're not muted, but we cannot hear you. Okay. Are you having troubles with your audio? It seems like it. We cannot hear you. All right. This is already time for, I think we would have to come back to your presentation, Ladipo, while we sort out the audio, making two presentation. Hopefully we can have this in the third session. I'm sorry about the technical glitches. But let's take a quick 8-minute break with the judges to just talk about this second session, and we'll be back in in 8 minutes to give a summary. All right. Thanks everyone for sticking with us until So thanks everyone for staying with us. We will start the next session in like 2 minutes. But before then, I would like to invite Khadija, one of the judges, to summarize our like feeling for the second session and maybe give some nice feedback, hopefully. Khadija, please take the floor away.
Okay, thank you. I think I'm just like amazed. I'm kind of lost for words because this is really interesting. I was here in the beginning. I saw how a lot of people started like from having no idea about this field to like what they presented today. It's just like so amazing to see. I like the fact that most of the presentations took out like through how they got their data. Like they just most people didn't just go and get us from like the existing data, but they had to like scrape their own data. And even those that had existing data, they had to like make it tailored to them and to the specific problem they're trying to solve, which is really amazing. And just some more constructive feedback. This is not to deter you or anything, but we just like to say that it would be nicer and easier if like the presentation materials are like self-explainable so that we don't have our attention divided in between trying to listen to you and trying to read what is on the slide. And also, most importantly, like in machine learning and in data science, what we need to consider is the people that would be using the technology that we are developing. So I think we should always like factor that into it, try to understand what they really want and try to tailor it in a way that they can actually just see the system. Like even if they have no idea of coding or anything, they can still use it and get the results that they want. So yeah, kudos to everyone and thank you very much. We are really impressed with what you presented.
Thank you so much, Khadija. Now we move to our first presentation for the third session, which is from Team Nkrumah, and this presentation will be given by Samuel Ekuma. Samuel, please, you can share your screen now.
Hello, can
Samo,
you
are
hear
you
me?
able to? Yes, I can hear you. Please share
Can
your
you hear
screen.
me?
Yes. Are you able to share your screen, Samo? Okay. While we wait for Samo, maybe Team Sankara is ready. Samo Oyeneye is sharing his screen. Oh, okay. I think another Samo is sharing. Samo Oyeneye, it's not your turn to share right now. I'm just going to stop your screen sharing. Samo Ekuma, can you share your screen? Okay. I cannot hear and I'm not receiving any feedback from Samo Ekuma. Maybe we would come back to him. Ogobe Charles, are you currently on the call? If you can say something, I see you on the call, but are you if you're ready to present, you can go next for Team
Okay.
Sankara.
Okay.
Thank you.
Let me share my screen.
All right, thanks.
Okay, can you hear me?
Yes, I can hear you.
Okay. Good day, everyone. My name is Charles. I'm a member of Team Sankara. These are the names of my members. Yeah. So we worked on a movie recommender system. We titled it Movie Sense. So let's get into it. So content overload is a problem that we all face today. We have a lot of information that a lot of people have access to, but they are not able to make the best choices because of a lot of information accessible to them. So movies too are not also exempt from this problem. And we thought it would be a nice idea if after watching a movie you like so much, you would get to see similar movies to it. So for our work, we got data set from movie lens. It had the data had a lot of we had a lot of data from the data set. I mean, we had almost 30 million ratings, 2 million tags, and about 330,000 users that rated the movies. So we decided to work with a subset from the movies. So we had to work with movies from the year 2010 to 2023, which accounted for about 18,000 movies. And that's what we used for this project. So we drew some conclusions and visualization from the data after cleaning the data. As you can see on the screen, we have the word cloud of movie titles. We also made some plots. We got the popular movies we got popular genre by the number of movies. We also checked for the distribution of ratings over the years. We also checked for the movies versus their weighted average, and the movies by the number of and the movies by the number of reviews. The weighted average, sorry, the weighted average is a column that we created. We use this to judge movies based on their popularity because some movies have 100% rating, but they might have been watched by just one person. So you have an average of what the person scored it as. So it's not enough to judge the movies by just their percentage. We had to create an average rating and a weighted average, took which comprised of the total number of ratings present and the total number of ratings for the movie themselves. So for the recommendation system, we utilized a content-based filtering system which uses a combination of the tags, the title, and the genre. We created embeddings with these columns, and these embeddings would serve as features that will be judged and we'll get a cosine similarity from the embeddings. So we first vectorized using the TF IDF, the term frequency inverse document frequency. So what this does is that it gives weight to words that appear in documents based on frequency of their appearance. So the more a word appears, the less relevant the word is. So after this, we got the cosine similarity after the vectorization. We use this to measure how close these movies are to each other. So for a quick summary of what we did, we have our user input. The user input is vectorized. So when the user input is vectorized, it is compared with the embedded. And then we select candidates that are closely related. We do this in order of their scores. So after that, we get a random sample of maybe 10 or 5 movies. Then these movies, we get useful information from the data set of the movies, like the TMDB IDs. Then we use it to get requests from an API that gives us the movie poster, the synopsis, and the runtime. So for the deployment, we use Gradle for the deployment of our app. We use an API, TMDB API, and we also deployed this globally using Hugging Face pieces. Let me show you a quick demo of the app. Okay, so this was what we came up with. This is what the app looks like. So we have the trending tab, top rated tab, and the search tab. So for the trending tab, we basically took movies from the current year and we judged them by their ratings. We also have the top rated tab. The top rated tab has movies that have very high ratings cut across all the years from the data set we are working with. We also got useful information from the API for the posters and the synopsis. Then for the main part, that is the search. So here we expect that the user gives us an input. So for example, let's take a movie. Let's take Inception. So when we enter the movie we are searching for, we click on the search button, a drop down appears. This drop down helps us to filter some movies that are close to the movie. So when you click on the movie, we have the information about the movie displayed here. And underneath, we have similar movies to it, the movies that are most similar to it. as you can see. So that's all for the app. Sorry. So returning back to the slides. So to improve on this project, we can obtain more reliable data sets and more information on the movies. The model can be improved by using techniques which capture semantic meaning and context of the movies, such as sentence transformer. So if we have um, if, if we use the sentence transformer, for example, it will capture semantic meaning and context of words that we use in the embeddings. It should help us create more. It should help us create a better similarity between the movies. So as you've also noticed from the deployment of the app, there were some posters that were missing and maybe some relevant information about movies that were missing. So if we have access to more robust API and more trustworthy APIs, they'll be able to give us information about the movies better. Another thing we can look at is personalization. We can make this a personalized user experience. Maybe if we collect data about about the region where the person is selecting the movies from. If we had better data sets that could also give us movies from particular regions that people have watched from particular regions, we might use that to create some sort of categorization that will help us better understand the user and show movies that the user might like. And so I would like to say thank you to the team. These are some of the videos that referenced we referenced while working on the project. I also like to say a very big thank you to our mentor for his help during the project. Thank you.
Thank you very, very much for your presentation, Charles. We have Ibrahim's hands up. Can you please go ahead with your question?
Yeah, hello, Charles.
Hello.
Yeah, nice presentation. I actually went through your app before now, so like, yeah, good stuff. But one question is, I was just curious, like, why did you go with the content-based featuring approach?
So we went to the content base because originally we wanted to go with a collaborative filtering technique, but we did not have access to data. The data set we had to work with wasn't so great, and we have to capture information from users, which might be a bit difficult for us to do. And most of the members of my team were not available because of their personal work. So we just had to do this plan.
Okay, right. Great job. Awesome.
Thank you.
Do we have any other question? Maybe we can take a quick one more question for Charles. Okay. Someone, Kumar, please start your screen sharing. Thank you again, Charles, for presenting. Great job to the team.
Everyone, can you see my screen?
Yes.
Okay. Good afternoon. My name is Samuel Ikuma. I'm representing Ikuma. So, we did a sentiment analysis on social media data, especially on Nigeria interest. Okay. So my team members were supposed to be five, don't know, along the line some broke up and mentor the solution. That's it. So introduction to this project. The topic of improvement project is sentiment analysis on social media NSAS specifically. So sentiment analysis on social media data. Um, we tend to want to know what really went on the public opinion that were going on during the demonstration, and also to do that we had to get our hands on the data we can get and get to know what was the public sentiment and the kind of data that was flowing then out then. So we had to get a data set from cargo because we couldn't script. So furthermore, sentiment analysis, this is just a brief background of why we did it and the whole introduction. To understand societal trends and aiding crisis management, the solution of sentiment analysis of social media data provides valuable insight on the influence decision making. So the main reason we took interest in this was because of the diverse understanding of the whole incident that happened back then. So we wanted to know more about the public opinion. We wanted to find out what were the public saying then. And the number one platform we thought of getting that information and getting the sentiment right was from a Twitter, which is now X. So that is what we did. So during the process, social media side, especially Twitter, were essentially in amplifying voices and disseminating information. So in order to identify something and comprehend the emotional tone of public discourse, this project will perform sentiment analysis, extensive collection of tweets pertaining to NSAS movement. So this is data set description. So before I proceed, I want to make some clearance here now. Our data set was supposed to be approximately 10,000 rows. So along the line, as we were working on it, we realized that the data is not labeled, and there's no how we could label the 10,000 rows manually. So we had to manually label the 5,000 that we could, so we can use it for the project. So first of all, we started by cleaning it, removing characters, removing URLs and non-alphanumeric characters, and we synchronized the word and removed top word as well and normalization, and we did lemmatization or scheming. The methodology/framework. The objective, first of all, was for us to identify public sentiment during the NSAS, which I have earlier stated, and uncovering key things and emotions during the demonstration. So the data collection, we collected data from forums, that is cargo, and data processing, we removed duplicate info and organize our data, skimming it and handling missing data and the special characters. So the sentiment analysis technique we use is we use NLP technique, and we also use some of the ML models such as naive Bayes and SVM, logistic regression, and robotic classifier. And the tools and technologies we used were Python, NLP libraries, scikit-learn. Training data, we use label data related to NSAS. So the solution, we use a methodological approach. The sentiment analysis of NSAS process we sought to ascertain the general public sentiment on the platform during the demonstration. So we follow the comprehensive procedures, which include data collection, pre-processing, and developing model and evaluating as well, and also interpreting it were all part of the analysis. So finding significant user dynamics, time shift, and emotional trends was the goal. An extensive processing, sentiment and notation process was used to train and validate the sentiment analysis model. The investigation took temporal factors into account, highlighting significant occurrences and important users. Extensive documentation, ethical consideration, and visualization enhance the results. So we tend to do visualization. We have to use pie chart to visualize the kind of data that was going out then. So one of the key advantages that helped us to actually come to enable us to get more insight in our visualization was
we going back to level like reading the tweet ourselves and now passing out, determining if this particular tweet is negative or positive. So with that, now we're able now to now draw conclusion with the data we had in hand then. So the project resource and the data set that we use, the data manipulation and solution is on our repository. So in our repository we have two digital notebook files. The first one was we first of all use sentiment analyzer, and after when we use sentiment analyzer to build the model, we realized that if we can manually label our data and see compare the error rate. Let's compare and see if this sentiment analyzer works better. We use it. If it doesn't, now we'll have to use the one we manually label. So after the computation, the error computation, we realized that the one we use sentiment analyzer on has an error rate of 49%. So we had to discard it. So we had to use the one we manually label. So in summary, sentiment analysis on social media can be helpful and reliable by the application of the methodology and framework of artificial intelligence and machine learning tools. By addressing this issue, the public, researchers, and policymakers will be able to gain a more accurate and nuanced understanding of the sentiment of the public during the NCAS process, which will be beneficial. So thank you, everyone. That is what I and my team were able to put together during the cohort.
Thank you so much for your presentation, Samuel, and great job to your team. Tayo, please ask your question. Please go ahead, Tayo. We cannot hear you, or you're not mute. While Tayo sort out his audio, Ibrahim, you can go ahead.
Can you hear me now?
Yes, good.
I can hear you.
Can I go on?
Yes, please go on.
All right. So I was saying thank you, Samuel, for this presentation and for your projects. Everyone who is Nigerian understands what the NSAS movement was and how key it was, how pivotal a moment it was in our nation's history. So well done for doing this project. But my question is on your data collection process or the data collection stage. I saw that you got data from Cargo, and I just want to find out, was there a reason why you didn't do the extraction directly from Twitter? Or is the data that you got on Kaggle an already existing extract from Twitter and you didn't want to reinvent the wheel? Just curious.
Okay. When we're trying to the project, the data was actually one of the main problems we're having because at first we thought about going to Twitter to get it ourselves. But when I gave it to Twitter, we already had a data set from Kaggle here, and the only problem is having that it's not labeled. Why not we get it and manually label it ourselves rather than going to get a new one ourselves and do it? So that was the reason.
So just to be clear, the data that is existing on Cargo, was it shown to be from Twitter or it is just another set of data?
It was shown to be it was from Twitter. Because
And it was related to NSAS.
Yeah, it was specifically about NSAS.
Okay, that's fine.
There's a word cloud graph, a word cloud graph about it, but I couldn't inject it into this slide. I would have just done it so you to see it.
Okay, that's fine. Thank you, Sam.
Okay, Ibrahim, please ask your question.
Okay, quick one. Can you hear me?
Yeah,
yes.
I can hear you.
So good job. I noticed like you did everything, sure, but like I did not see results. Like, what was the feedback you got, the insight from the data? I didn't see that.
Okay, I like what I did was the data was already there, so we're trying to build a sentiment analysis model. It's not that I never knew if we're going to get any outcome, but we did a model which we did the evaluation. We used the SVM report
No. Wait, hold up. I hear you, right? Like initially you said the problem or the statement was like looking for public what the public were saying. So I was expecting to see that in like in your results, but like I didn't see that. It's just something you should note for next time.
Okay. Actually, we did it, but we couldn't insert it into the slide. Sorry for that. So there is a pie chart graph on our code on GitHub, which has this tweet sentiment distribution. And in that tweet sentiment distribution, there was more of a positive tweet out there during that period, during the period of NSAS process. That is it. Sorry, we couldn't insert it in here.
Okay, fine. Nice job.
Oh, sorry. So the conclusion here now is that during the NSAS movement, there was positive sentiment or negative sentiment?
Yeah, there was positive sentiment, and the percentage of neutrality was about 0.7 neutral tweets that were going out then, while the negative tweet percentage of negative tweet was around 0.2, which is 20. So the percentage of positive tweets that were going out there were higher. But it depends on who is labeling, because personally, I don't see a tweet criticizing the government of what they are doing wrongly as a negative tweet. So I had to classify them under positive tweets. So after I did all the labeling and did all the feature extraction, that is when I got the pie chart graph that see that okay, there were more of positive tweets out there during this during the NSAS movement.
Okay, we need to delve a little bit deep into that. So positive means that people were happy. A lot
No,
of
not that.
happy.
Not that people were happy. People were actually talking more about, like, people were not on the side of the government. Because that is my own sentiment when labeling. Because people were okay. Let's assume somebody says, it cannot be well with Buhari. I classify that as a negative tweet. You know, so I label it negative. You get it? Okay, when somebody is calling out to the police, stop killing our young youth, I classify it as positive.
Oh.
You understand? I classify that as a positive tweet. When somebody says, why would police be harassing young men because they are carrying laptops? Classify that a positive tweet.
Okay. So in this case, we can say that positive means that like on the side of the movement.
Yes, on the side of the
People
movement.
on the side of the NSAS movement.
Yeah.
And
why the neutral tweet were people that were neither on the side of the movement or against the police brutality.
I think this is great. Like now I understand it better, but we should be central of your presentation. Like you should terminologies needs to be right, because people think of sentiment or positive or negative in a different way. So we need to first understand what positive sentiment means. Maybe you said it, maybe I missed it, but now I think I understand a bit more about what you explained. Okay. Did anyone want to say something before we move to the next presentation? Great. Again, thank you so much, Samuel. Please give Samuel a virtual round of applause. Our next presenter is Ladipo from Team Ransom Kuti. Ladipo, please share your screen now. Can you talk? I cannot hear you if you are talking.
Hello, can you hear me now?
This is good now. Finally, yeah.
Can you see my screen?
Not yet. You need to share again, please.
What about now?
This is good now. Thank you.
Good afternoon, everyone. My name is Kadiola Lakpo, presenting a solo project in the team Ransom Kuti for Cohort 8. Title of the project is Transcending Barriers, a comprehensive framework for sign language video translation, speech generation into low resources language in Nigeria. I'm very sure everyone has, at one point in time, encountered people who are hearing impaired, and I've been seeing them communicating and be wondering, what the hell are these people saying? What are these people communicating with? In Nigeria, as vibrant as we are and as very population of a large population, there is a part of community, the sign language, the Nigerian sign language users who are deaf, who are hearing impaired. This community is a bit marginalized, even though they have about 70 million relying on this sign language. They face a lot of challenges, from limited education access to even employment opportunity. There is not, even in developing countries like Nigeria, most times there is not enough adequate communication support facilities for this particular individual. This also results in children not having a good quality in schooling, leading to higher unemployment rates, even leading to social isolation. Because as one knows, human beings, communication is very important to us. It's the key fundamental human element. So some of the challenges being faced by the community are education challenges. Due to the communication barrier, most of these sign language users, deaf impaired, you don't usually see them in universities or in even public, private or public school. You only see them in specialized schools, which is, to me, is not that everywhere in the country. There's also a communication barrier in terms of communicating with other people. Most people speak most people in Nigeria speak either English, and the many percent speak either one form of the local language, be it Yoruba, Igbo, Hausa. So communication barrier is a bit difficult. Even a parent who gives birth to a hearing impaired child will have to find a way to go and learn sign language, which is a bit difficult. And that's a bit of a communication barrier. There's also limited employment opportunity. Most organizations don't tend to have adequate facility to accommodate these hearing impaired individuals. And most importantly, there's social stigma and discrimination. Most people, when they tend to see these hearing impaired people, they tend to want to stay away from them because they feel as if they are kind of like an alien. So how can we solve this solution? How can we make it in a way that these hearing impaired people can communicate with non-hearing impaired people and have a way of to further develop even their lifestyle? Introducing NSL to audio framework. NSL to audio framework is the aim of the NSL to audio framework is to translate Nigerian sign language into a spoken audio, or one of the low resources language here in Nigeria, be it Yoruba, Igbo, Hausa. Particularly, this project is aimed at Yoruba specifically. To solve this problem, the project decided to break down the solution problem into three phases, into three stages. The first stage is a signal to text, which will build a transformer, translating that signal, that sign language to text translation, to English text translation. On the second stage, we will use a pre-trained model by Meta to translate that English to a Yoruba translation. And on the third stage, we will use that Yoruba text translation and use another pre-trained model by Meta again to translate into a spoken word generation. This pattern was able to solve the problem, and we'll be able to solve the problem in a much better way instead of us building a one model or architecture to try to solve it awesomely, which will not be better. Here is a high-level system design of the entire network, of the entire framework on system. Firstly, the user signed video is being sent from their browser or on device to a, firstly, the video is being extracted using MediaPipe. MediaPipe is a light framework, a machine learning light framework that helps to extract key points and key points, assign pose, hand pose, face pose, and the rest of that. We deploy the MediaPipe will be deployed on the client side browser because the framework is a bit light, so it can make sure that the sending of the video is quicker. Then the framework, so the key points is then sent to the system, our NSL to audio system. Firstly, the framework, the key points frame rather, is being sent to the sign signal model. This will convert the English to text model, convert the sign language to English text, after which the model is being sent down to the second stage, which is our unified model. It will convert the English text to Yoruba text, and after which the model again is being sent to our third stage and final stage, which will convert the Yoruba text to an Yoruba audio. And then the created audio is then sent back to the users. This way we can scale the by hosting it on Google Cloud, it allows scalability, it allows many users to be able to use it without actually finding a lag in the system. And by also using MediaPipe, it means that the future extractions will be able to be quicker. Tokenization will happen between this stage, the lot of cleaning process. Yeah, at each stage of the model, rather, there will be a cleaning process. I think around here we have to tokenize the, we have to clean the data, remove the NAs, also at the same time try to do a little bit of normalization before passing here. And also at each stage of this down model, the text predictions are tokenized. The data to be used to train the second stage and third stage have been, we use a pre-trained model, so there's no training there. For the first stage, there is no pre-trained model available, so we have to train the model for it. The data we're going to use is the Google ASL finger spelling data. ASL is American Sign Language. Nigerian Sign Language and American Sign Language are not different at all. They are basically almost the same thing with a few minute difference. So the architecture to train our model is the transformer architecture, which is a very popular architecture in our world today, being used to solve complex tasks. Our data is about 100 gig, about 100 gig, and the model is a model that likes to consume of data, so that is a bit balanced. Before the data, the frames, that's the key point frames, are being passed into the model. They'll be cleaned, tokenized, and then we train the model over several epochs at the same time, try to evaluate the model using the Levenshtein distance. Unfortunately, at this time, there is no demo for this system. Currently, right now, I am trying to write the pipeline for training the model. That's where I am right now, writing the pipeline. The model architecture has been written. So right now, I'm just writing the training process, trying to utilize GPUs, cargo GPUs, and trying to make sure it's distributed in a distributed way, so that in case the training process is disrupted, someone can pick up and restart gracefully. Hopefully, in the next 2 weeks, we will have completed the model training and then deploy the system on the cloud and make available for public testing. It's been a very nice project, and I've been able to learn a lot from this project. One of the most important things I think I learned from this project was the achievement of critical roles technology will play in fostering inclusivity and the recognition of the potential for AI-driven solutions to bridge communication gaps and for marginalized community. Obviously, this project is not a portfolio project. I think it's a project that needs to go out to solve issues for people. And for that, we have a future project roadmap. And one of the future project roadmap is in each of stage of the model, there will be large models. So we want to try and reduce the model to be able to deploy it and also to make sure that when we do later put them on devices like mobile phones and smartphones, it will not be consuming your energy of your phone, and the latency will be fast. Also, to also improve the latency of the model, we want a quick, fast translation. It would be really better if, as you're cameraing or sending your videos to the system, they're getting your predictions or your audio output at real time. And four, we also like to conduct an outreach program to raise awareness about the system. Like I said, this system is not really a project system. It's something that needs to be out there to people to use to solve people's issues. I welcome contributions from the community to enhance this project. You can visit the GitHub repository at Cohort 8 and some platform. Open an issue, share feedback, report any bugs you think we can encounter. You can even help to improve documentation of the project, make it accessible for people to use and contribute. Thank you very much. Yeah.
Okay, well, thank you very much for your presentation, Ladipo. Do we have any question for him? We can take 1 to 2 questions. Fortune, please go ahead.
Hi, Ladipo. Good day.
Yeah,
project sounds interesting. I like the step-by-step idea. So I want to get a sense of the challenge you faced with the very first bit, which is, I mean, the part that involved you training. You mentioned that you already have the architecture down, so I'm wondering why you guys could not, train it before now. That's the first question. Then I understanding that that model is not completely available, and you already said we don't have a live demo. I want to still get some context as to how much you've explored the other models. That's the Facebook's NLV 200 model for the translation, and then the other model, I think it was MMS. Is it MMS?
Yeah, MMS, multilingual speaker.
Yeah.
Like
yeah, because that last one in particular, because I tried it because I was using it a while back, and the audio in Yoruba wasn't the best, let's say. So I'm wondering if you considered that, and I think there is also like a limitation with I don't say context, so like the quantity of information you can pass to it to actually generate audio, like it might cut you off at some point, so you have to like do a bit of splitting your inputs into like patches so that you actually get full results. That last one might just be something to think about. I don't know if you consider that. I just want to know how much you've experimented with the models with this one. That's the first question. Thank you.
On the first part on training, the bug I'm facing right now is because I'm using Kaggle training to train, and the bug I'm facing right now is I'm also using TouchRun, PyTorch TouchRun to handle basically restarts. So I think TouchRun is not running. TouchRun is not like recognizing that there's a GPU active on Kaggle. So it's more of me diving back to documentation on TouchRun and trying to see how to solve the communication issue by TouchRun to find that GPU, because that's just the issue I'm facing in training right now. The training pattern has been written, the model architecture has been written, but I think the bug is from TouchRun. TouchRun not recognizing that there's a GPU I'm in a GPU environment. Instead, it's telling me that I'm not in a GPU environment. So that's the reason why.
So we have to.
Sorry, let me answer the second one. On the second one.
I'm sorry, I have to cut you short, Ladipo. We can put that offline. You put it up. You can continue the chat. I'm sorry to be the breakout nice time this time around, but we need to move on. Please put it in chat and continue the conversation offline. Thanks a lot again for your presentation. So next we have Samuel Oyeneye to present. I will share on his behalf because of technical glitch. So Samuel, please go ahead with your presentation.
Yeah, thank you very much. Yeah, my name is Samuel, and I'm part of the team Ramsakuti solo team. I'll be presenting my project, which is on adaptive melodies, a user shift preference music recommendation system. The focus for this project is to So uses advanced machine learning to adapt to changing user music preferences. A little bit of background. The motivation for this project is from my own personal perspective, looking into how music recommendations are quite static. So human beings are irrational human beings, irrational people. So we actually tend to feel different things based on different time periods. So based on this, recommendations have not really gotten to a very good period of good amount of satisfaction. So this proposed solution to resolve this issue, yeah. So proposed solution for to resolve this is this project aims to use an existing research, implementing a user shift preference system, using algorithms like time decay, collaborative filtering, and graph neural networks. I'll get to that in a bit. And the overall project goal is to enhance user experience, whereby they get satisfied recommendations. And we see the GIF there. The lady gets to understand the music she when she gets a breakup. Yeah. Next slide, please. So a little bit of into the data source I went into. So I sourced a data set from the now playing recommendation system benchmark data sets. This data set is a general collection of user music listening events gotten from Twitter. So the data set is actually a research work for resolving different issues with recommendation data for music recommendations. So based on any kind of recommendation you want to make, either it's a sequence based recommendation or a context aware recommendation you want to do, the data set is rich enough to provide that. And just a section of that data, which is the one I use for the user shift preference music data set, as you can see in the graphics provided. Next slide. So technical approach. This technical approach I used, which is time decay, collaborative filtering, and graph neural network. As we can see, the time decay collaborative filtering is just it's similar to that of collaborative filtering. Collaborative filtering uses a user item interaction matrix, but the time decay actually dwells more on the time factor, which gives more weight to recent interactions for the user preferences. So the graph neural network is kind of a relational data network that actually gives nodes to it represents the user and the item with nodes, then also edges as features that merges the relationship between these interactions. Yeah, next slide. Okay, so the model building process. The first process was the data gathering, the data gathering part where I sourced the data. Then reason for this is because it is comprehensive enough for getting user interactions based on this data, and also due to ethical issue concerns on privacy of users. I can't get Spotify data, which is much more robust, but then and also they don't provide model building with their data, and due to user privacy concerns. And also this data is very good in terms of that as well, because it uses ID instead of instead of user or their listening kind of monitoring data. So it is very, very good for this model. The model training part is where I implemented the model, the time decay collaborative filtering. I implemented scikit-learn, which also which is sorry. So I implemented scikit-learn, using truncated SVD for dimension reduction. So one thing I noticed when I was training the data at first was where the data was full of sparse data. So it couldn't generate a lot of dimension matrix for the user interaction matrix for the data. So I used this truncated SVD to reduce this factor, and also get time decay weighting for using the decay function. I use exponential decay function for that actually. So next slide. So current progress. This is the project is still ongoing, and it's still in its early phase. I just completed the time decay collaboration filtering parts of the project. Also implementation of the project, and also the comparison with the graph neural networks data. Challenges faced during these projects, data source. So I experienced issue with getting the data I wanted at first. It took me a very bit of time to get that resolved. So I overcame that issue. So the data I actually wanted to get was the Spotify data, but then it wasn't available, and also I was not able to get those data. So I resulted in using the now playing data, which is an open source free data set. Problem with large data as well. So I also had issue with the data I first got was one of the Spotify Last FM data sets, which is about 8 gig, kind of 8 gig large 8 gig size, sorry. So I couldn't load the data sets due to GPU runtime and stuff like that. So I had to result into using the now playing data set, just a subsection of data set, which is kind of important for the which is important for the user shift preference music recommendation. And also data sparsity. I got into issues with the data sparsity of data. So I explained that earlier, that I used truncated SVD to resolve that. And as you can see, preliminary results here, giving recommendations to user by their track ID. So it recommends different music that includes time preferences for the user at random. Yeah. Okay. So next step and conclusion. So I'll be keep working on the project because it's still ongoing, and I would like it to really solve real world problems with adaptive music recommendations. So I'm moving towards building the GNN model, and also comparing both algorithm and integrating it into a system where it works as a functional model. And also potential impact. So one thing I also like to say is the potential impact of the adaptive melodies. It's also impacts user experience, and also innovation in music streaming services. And for contributions, and for any question or anything, my personal info, my email and GitHub is here, as you can see.
Thank you so much, Samuel, for your presentation. This is very nice to see. Okay, do we have any question from the judges or audience? I don't see any hands up yet. So, okay, Emefa, please go ahead. Emefa, please go ahead.
Hi, can you hear me?
Yes, I can hear you.
Okay, so I wouldn't say a question, but a suggestion, because the presentation, the inconsistencies with the presentation, move from a darker theme to a light theme. It doesn't make it look cool for me. No images, no figures, nothing. It's like you're just writing words, and I'm not able to relate. Not to say you didn't do well, you did well, but I really loved the previous presentation because it has images, it had diagrams, and you can relate. You don't have to read so much. Okay, but if the project or the presentation has only words, you're not able to relate. There's no figures. So what did you do? What are the figures? What's happening? Because if it's just the theory and all that, it makes it difficult for me to relate. But if there are figures and there are diagrams to be able to explain the whole flow and what you do and the conclusion, your final results, then I can be able to relate with everything. Not to say you didn't do well, you did well, but just for future presentations. Thank you.
Thanks for the feedback,
Thank
MFI.
you.
Do we have any other question, feedback, suggestions? We can take one more and then we'll go to the next presentation. Okay. It doesn't seem like it. Well, again, congratulations to all of the presenters that have presented so far. And thank you so much for your presentation. We will move next to the next person, Samuel. Thanks again. So the next person to present, I believe, is Chris, right? Is Chris on the call? Do we have Chris on the call? Chris Adai, are you on the call?
Yes, I'm here. I'm here. Yeah.
Yeah, please share your
Can you hear
screen.
me?
Yeah, I can.
Okay. Oh, give me a minute.
So while Chris is setting up, yeah, it's your top. I have you on the agenda. I just want to confirm that you're presenting. It's your top. Can you hear me? Can you send me a chat? I tried to send you a chat. Just let me know if you're presenting so we can know if you're next or. Thank you. Sim Elnadi. Yeah. Please, Trace, try to stick within the 5 minute budget if possible. I'll be
Okay.
really over time right
I'm
now.
sharing my screen now. I don't know if you're able
I
to
can
see.
see it, but put it in like a presentation mode if possible.
Okay. I don't understand. Sorry.
Presentation, you can click on the slideshow. That would.
Okay. 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 Yeah. Sorry, I'm using Google Slides.
Slideshow button is just to your right.
Not
Look
too
at
cumbersome.
no, look at the right. Look, just look at there is something called there's a button called slideshow just beside your
Okay. Okay.
profile.
Okay. Yeah. Okay. Okay. Good day, everyone. My name is Ada Christopher. Team Ransom Kuti Solo Team Ransom Kuti. So my project is titled Editing Credit Card Approvals. Okay. So basically, my motivation for this project is I discovered commercial banks basically receive a lot of applications for credit cards and many of them get rejected for reasons like high loan balances, low income levels, and also previous reports of their um, credit behavior. So, but the process is tedious and somewhat repetitive. So, the building a model to automate this process and predict, the outcome of applications motivated them to take on the project. For regards the data set, I refer to UCI. I got it from UCI. So it was the data set was somewhat, encrypted for privacy reasons, and also I still had to refer to some um, explanations on the data set to be able to make sense of it and label accordingly. So uh, yeah, some of the labels I gave them, because in the actual data set you'll just be seeing UG and all of that. So I had to just label them. And I also had to do a lot of pre-processing. I had to do a lot of pre-processing before even coming to splitting the data set and into train and test and all of that. And also, even on splitting, I still had to still do some minor pre-processing as well. Um, like for the train set, I had to also do feature selection to drop some features that don't really have any impact on that are not really considered normally for approval, like license and zip code. So I had to drop stuff like that. Then I had to rescale the features of some of the data, like the credit rating, because they are in range of numbers. So I had to rescale them between to be within the range of 0 and 1, so that it will be more effective. If I had used if I had just used the numbers of the credit rating like that, if data is fed into it for a test and it doesn't really fit, and there is sort of distortion in the figures, it will cause some errors. So in order to preserve the integrity, I had to rescale that. I then fit the logistic regression model to the train set, and I evaluated the test set with respect to the classification accuracy, and I also had to look at the confusion matrix to see how to assess the level of accuracy that the model can predict. I so my model, well, I don't want to use the word luckily, but I got a very, very high level of accuracy even without great searching. So, but I still had to, put in the grid searching there, should in case for further, should a data be fed into the model that require, that will not be like this. So I had to do some grid searching to know the parameter that best fits the model, and all of that are in the notebook. Then, yeah. So, in summary, the my analysis of the data set for the credit rating and all of that shows that it's very possible and it will be very easy to use the model to predict. It will make the work of the um, banking institutions or financial institutions that want to issue the credit card out to make it easier and more productive. And they can also still check further manually on their own is allowed and all of that. So there were four factors that had a great impact from my analysis. One is the prior default. The second is the years employed of the applicant. The third is the credit score, which is one of the four of them is very, very key. Then the income level. So these were the four main factors among other features that really influence the approval. So this is it about my presentation. I don't know if anybody has any question.
Wow, thank you so much for your presentation, Chris. Any question? We can take one question from the audience or the judges. Do you have any question? Okay, doesn't seem like it. All right, so we will move to our last presentation for today, which is from Ahmed Ibrahim team. The presentation will be given by Peter Oni, or Elisha will share his screen. So Elisha, please share your screen now. That you can start presenting. Elisha, are you able to share your screen? I think Chris is presenting first. Okay, I'll go on.
Okay, let me stop sharing my screen.
It's all right. It's all right. I already stopped it for you.
Okay,
Thank you
thank
so
you.
All right, great. All right, please refer to start. Peter, can you talk? Are you saying something? We can hear you. Well. Okay. Elisha, can you present? We cannot hear Peter only.
Hello.
Okay, Peter, we can hear you now. Oh, sorry. Are you saying something? Your audio is extremely low. No, not, I mean, a little, it's better, but it's not, it's still very low. Now we cannot hear anything. So do we need to get that fixed or something? Is there someone else on the team that can present this slide as well? All right. Give it a few minutes, then we will reconvene as judges to discuss about this session. And when we come back, we will just give a closing note. Please stay with
Hello.
us.
Is it better now?
Yeah, it's better now. Let's try again.
Okay. So good afternoon, everybody. I'm Peter Oni from Team Ahmed Ibrahim, and the solution we're presenting is the Lagos house pricing model. So what we set out to do was to build a model that could predict house prices in Lagos State, because we know how wild house hunting is in Lagos State. I mean, if you've ever hunted for a house in Lagos, you know the struggle with the agents. So we wanted to build a solution that could put your options on the table, show you what you can get with what you have, your budget, and where you can get it from. And so we went ahead and built a very simple model that could do just that. Next slide, please. Yeah, next slide. Yeah, so just like I've explained, it's a model that predicts house prices. Actually, we wanted to make it very comprehensive. We wanted it to include house rent too, because that's like the major thing that Lagosians look out for. They want to rent houses in better locations, and they would like to know the prices of those houses before they go on and check them out. But unfortunately, we couldn't get the data sets that would work for that. The data set we got that had rent in it was not properly labeled. When we started cleaning it, we realized that a lot of the columns there didn't match the description. And even though we wanted to even label it manually ourselves, we just couldn't do it. It just wouldn't work without us manipulating the data set. So we had to go with what we got on Kaggle. And that was a Nigerian data set we got on Kaggle. So we just extracted the Lagos data set from the old Nigerian data set. Next slide, please. Yeah, so our data set had 7 columns initially. 2 of them were categorical, the title and the town. So we had to clean and encode it to numerical data. We use one auth encoding, and that's what we have here. We have the bedrooms and the title and the town. Next slide. So yeah, so the first visualization was to check the most expensive houses, just to see how much the location affects the price of houses in Lagos. And this is what we got, Koileki, and all those were the most expensive. Next slide. So also, we also wanted to see the influence of the different types of houses on the price. But what we have here shows that it doesn't seem like it's affecting the price at all, because we have the same level of prices for different houses. And the most expensive house, detached duplex, normally in reality, that's not usually the most expensive house in Lagos State. Sorry, next slide. Yeah, so like we have here, we after visualizing, we realized that the location of the houses was like the major variable influencing the price of house, not just the number of bedrooms or the number of bedrooms or parking spaces. Those were just like mediating variables. So we went on to modeling, and we used Keras. We used Keras for modeling. We trained our data set on Keras. And this is plot for our loss, training loss, and validation loss. We used mean absolute error. Sorry, go back. Yeah. Sorry, go back to the plot for the validation loss. Yeah, so sorry, next slide. Yeah. So when we trained the data on Keras, to the plot for validation loss and training loss, the slide. Yes. So this is what we got. And our model stabilized here at 500 airports. So epochs rather. So we went on and made predictions with the model Xnet, and we evaluated the results, and we used R squared, the coefficient of determination, to see how much of our excess is predicted by a model, and we got a result of 0.9. I'm not surprised that you are, but this was the evaluation, the result of the evaluation, R squared. So we thought we were getting it wrong. We had to design a new model. We used random forest to check if we're wrong or not. And when we trained it with random forest, the result wasn't as good as what we got for Keras. So we just went ahead and designed our demo with the Keras model. And Elisha will be showing you a demo.
Okay, Elisha, can you show the demo?
Can you see it?
Yes.
So yeah, this is our
That's
demo.
nice. I have a question for
That's the
the
end of our
kind of
presentation.
I have a question, Elisha, before you go. For that same building type, like in your data set, how much was it? Is it up to this amount that is being predicted? Or is it more than this amount? And if it's more, how much more?
Please
So
come
for
again.
for a terrace bungalow in Apapa with 2 bedroom, like typically, how much is it in like from your data set? Like from your true data. So I suppose that you have some building type which are terraced bungalow. It's maybe in another state, another town or something like that. So I'm asking you now, what is the typical range for a bungalow in your data set
Also, a
with
follow-up.
this?
Sorry, just following up on your question. Is this amount the amount to rent it or to buy it?
The amount to buy it.
Yes. Yeah, so like I explained, this is predicting the prices of the house, the amount to buy it. So part of scaling this model is getting enough data that could help us predict for the rent too. But for now, just the two of us, we couldn't get that. So we're only predicting the price of the house, not the rent.
Okay. All right, no problem. Great job so far. You haven't addressed my question, but maybe we'll talk about it.
Yeah, we need to go back and check the Excel file or go
No
back to our
worries.
code. Check it.
That's a good answer. Thank you for responding. Okay, thank you so much. Do we have any other question? We can take maybe one more question. Well, great job, everyone. So let's take a quick 5 minutes break to discuss and summarize. And when we come back, we will just give like a closing note. Thank you so much, everyone who is still with us until now. We appreciate it. We are way like late, but thanks for being here. We're almost done. See you in the next.
Like,
Well, hi everyone. We're back. Thank you so much for waiting and staying with us until now. So before to wrap up the last session, the third and the last session for the day, I would invite Amy for to say a few words. Okay, Emifer. Emifer, can you hear me? Can you unmute in case you're saying something? Emifa.
Yeah.
Okay, thank you. Can you,
Sorry.
you can go ahead to give the feedback.
Okay. Okay, so first of all, I want to thank everybody for taking the time to work on the project and also making time to present this. So far, so good. I mean, all the teams have really worked well. We are glad we're able to choose various topics in different fields to um, present on. However, we have few, should I say, advices that you could take for future presentations and future projects. And when you are presenting, to me, it looked like most of you did really, really amazing. Looking at the repo on GitHub and then what you presented, and it feels like most of you left out the relevant things you're supposed to have presented on. So when you're presenting next time, it could be a project, it could be anything else, just make sure that you put in the relevant things that we need. Because if you leave out the relevant things and you give a presentation, you may have done a very good job, but your presentation and the content of your presentation will go against you. And someone might have not put a lot of work and effort, but if the presentation style, the content is good, the person is going to be chosen over you. So just an advice that next time when you do any presentation, it could be academia, it could be industry, it could be anything. Make sure that you include the relevant things that we need to see, the figures, the statistics, the conclusion, the problem statements, and also everyone can follow, okay? The graphs and everything, more less of the text. And most of you had the presentation slide full of text, like too much words, forcing the judges or whoever is listening to read. Less of text, more of diagrams, more of the figures, more of statistics, and the conclusion, the problem statement, and the conclusion. So your conclusion is going to solve that problem statement, okay? But aside that, all of you did really well, and congratulations to the team.
Well, thank you. Thank you so much for your kind words and advice, Emefa. I have just seen in chat here that Sean, who is the mentor for Salase, said the person that was supposed to present was medically ill. I'm very, very sorry to hear that, team. So like does the team still want to present? I suppose we can have 5 more minutes because you've worked so hard on this. So if you want to present, we can do that now. Otherwise, we'll just wrap up. Can someone speak up if they want to present? And then we can act. Okay. It doesn't seem like that. Again, I am sorry. I just saw this and it seems like you also just sent it a few minutes ago. So we will move on to the closing remark for today and close it up. Thank you again to every one of you who have stayed with us until right now. My colleague Tayo will give the closing remark and I'll just put the cherry on top of the cake to seal it off and give some future outlook. Okay.
All right. Thanks, Teju. Thank you very much. So again, we want to say a big thank you to everyone for attending today's demo, but most importantly to everyone who has been involved from the beginning of this cohort, and that goes out to the organizers, to everyone who answered our calls for volunteers, and you, the students as well. So this is a quick snapshot of the current organizers. We have the steering committee, but the biggest shout out to everyone on the course instructor team, the communications and mentors and project management. I mean, the steering committee has been a big, you've been a core part of the AI Saturdays Lagos movement from inception. But, and so everyone's support has been there. We've been consistent, but we really want to appreciate everyone who has taken this mantle. They heard the call, they applied, and they've been with us from the start to this point. So Fortune, Sandra, Ejiru, Shale, Yosha, Fola, Shadrach, Darasimi, everyone. We really appreciate you guys. Next slide, please. And of course, all of our volunteer instructors. I mean, if anyone understood how the cohort has been run before, it's usually just one or two people who take the classes from week 1 to week 16. So it's very good that we got a host of instructors to volunteer to take 1 or 2 classes during the session. I can't go through everyone's name right now, but these are the faces of everyone who has made this cohort very possible. So we see you, we appreciate you, and we are really grateful. And then to our lab instructors as well, thank you very much for all the time that you've put in. I'm sure the students appreciate it. We, the organizers, also appreciate it as well. So thank you very much. And also the people behind today's event, which is our demo day. We really appreciate you guys for helping to nurture and mentor the students to actually go from ideas to churning out actual products that amongst the judges and amongst ourselves that we've seen today could actually end up being market-ready solutions as well. So your input, your impact doesn't go unnoticed, and we really appreciate it. So thank you very much for all the work that you have put in, and we hope to see you guys next time. And also, finally, to our judges who have sat through all of the presentations today, who have given constructive feedback, who have sat down and even offered some of their time beyond this event and beyond the cohort to actually help to continue to refine and fine-tune some of the solutions. A big thank you to everyone involved. And like the previous slide had said, it has taken a whole village to get this to where it is today. And again, it's all nothing but appreciation and gratefulness from our parts as the AI Saturday team. And thank you so much. So Teju is going to take us through what is coming next with AI Saturdays Lagos so that you can keep in tune.
Thank you so much. Thank you so much, Tayo. Like, I feel incredibly proud to work with just an amazing team of selfless people. Like, I cannot begin to say, like, I cannot express how thankful I am to be working with all of you and to have you whole support us. Like, I'll just send an email to each and everyone, and then they'll be like, of course we would help, of course we'll be a part of this, without a second. And I know every one of you are very, very busy. Like, this is not your main job. You have other priorities, responsibilities, but you just have a strong sense of serving the community, of like sharing your knowledge, of giving back, because maybe at some point you were also on the other side of the road where you were receiving. So I'm really grateful to be doing this with everyone, and this is our community. This is all of us. This is our like you said, it takes a village. Education is everyone's responsibility, not just one person. So I'm just glad that we are doing this together, and thank you so much. So some of the questions we have been receiving is that, so what's next? When is the next cohort 9 going to happen? So currently we are still deciding, but vaguely we should have the next cohort happen in 2025. Yes, not 2024, not next year, but cohort 5 should be somewhere around a spring, March or June 2025. As you know, cohorts takes a lot of time, and people and we need to recharge, I suppose. So we will come back stronger with more team and take all of your feedback to make it better. So if you're interested in being a part of it, maybe as a scholar or volunteer, you just want to be part of Cohort 9, you should fill this form to let us know so we can reach out to you as we come closer to the date, and we can plan together, or you know, what the future holds. And but another nice note to tell you is that research cohort is coming back. So we are planning to have our second AS at the Lagos research cohort happen next year, sometimes in April or May. More details to come. So this is less, it's not the same length as the cohort. So we're currently planning for about a month research cohort, which we will be discussing some research papers and also working on a project that we already have ongoing in the community, or you know, we will provide more details in the coming months, I suppose, after we are fully recharged from this cohort activity. So this is all we have for you for AI Saturday Lagos Cohort 8. And I'm going to leave you with one last quote, which is from President Nelson Mandela. It always seems impossible until it's done. So thank you so much for joining us today. This is AI Saturday Lagos. Toodles.